Ready? The best case scenario is tragic. There's nothing we can do. Even if you come in 6 weeks before, I'd still be telling you the same thing. Imagine hearing this in reference to yourself or a loved one. I don't have to imagine. 4 months ago, I heard this from my dad's medical team. My dad had been in the hospital suffering from medical problems for 4 years. None of them were cancer. The last time he was hospitalized, he was battling an aggressive form of lymphoma known as Burkitt's lymphoma. He had only had it about 4 to 6 weeks, and when they made the diagnosis, he died 2 days later. As soon as I heard the phrase, "there's nothing we can do," and that we have no options, my reaction was, what do you mean there's no options? In this day and age, there's an option for everything. To me, that's unacceptable, and that's when I decided to become an oncologist. Because the truth is that there are options available, they're just not accessible. I'm talking about stem cells. You should support stem cell research because of the possible ways of obtaining stem cells, the progress that's been made, and the potential future uses of stem cells. First, I'd like to discuss some of the possible ways to obtain stem cells. Embryonic stem cells are the most controversial, or the ones that we always hear about. They're taken from embryos that were used for in vitro fertilization, and the family has chosen not to have more children or just not to use the embryos for whatever reason. It's a 5-day-old cluster of cysts. It's not got a beating heart or anything. It's all the cells are still in a state of ready to become whatever they need to become in your body. They haven't differentiated, they haven't specialized, and they have no abnormal defects yet. This is why they're considered the pinnacle in stem cell research, because you can do anything with them. Another option is umbilical cord blood. If you've ever had a baby, you know, you cut the cord and they pitch it. Now you have the option of banking that cord blood for future medical use in your family, donating it for research, or donating it for use by other families. It's almost always a match for people because, again, it's not embryonic state, but it's young and it hasn't specialized yet, so you can use it for many, many things. Another source is harvesting from adults. You can actually get it from tooth pulp now, bone marrow, which has been done for a long time, and skin cells. Next, let's cover some of the progress that's been made in stem cell research. Well, actually, let me go over my graph first. I put this together with statistics from the National Vital Statistics Report from 2009, because 2010 isn't out yet, and the American Cancer Society from 2010. This is the number of births per year in the U.S., live births. So equate that to cord blood. The number of teeth extracted every year in the United States is 20 million. New cancer diagnosed in the U.S. is way down here. People that are going to die from cancer in 2010 is way down here. So just compare these two to this. This is how much cord blood is out there. This is how much tooth pulp is out there. These aren't controversial. And a lot of this is just being tossed as medical waste. These people need this. They can use this. If they can't use it in them, they can be researching on it to find new ways to help these people. So it's really something to consider when you think donating it or pitching it in the trash. I mean, which is really worse? Stem cells that have been found in tooth pulp are actually some of the strongest stem cells in the body. They replicate faster and for a longer period of time than any other stem cells, including the embryonic stem cells. Now, adult stem cells are a little tricky because they are specialized, so a lot of them can only turn into certain type of cell. Like if you got it from your liver, maybe your liver, your spleen, your pancreas, things like that. But they're not as easily manipulated, but they are making huge strides. Like from the tooth pulp, so far, they've been able to create bone, muscle, including cardiac muscle, and insulin-producing pancreatic cells. Stem cells are actually being used a lot in clinical trials with people with juvenile diabetes right now because of this. The cardiac muscle is being grown in the lab. So if you have a heart attack, they can grow you a new piece of muscle and put it in, and your heart will repair itself. That damage is gone. The skin cells are really amazing. They have found a way to take a skin cell, just a skin cell, not necessarily a stem cell, just a skin cell. They can do a process and actually reverse it back to an embryonic state, not using an embryo and not using an egg, but it has all the same capabilities as an embryonic stem cell. They can turn it into nerve cells, cardiac cells, and these are actually stem cells, but no, they don't come out in the shape of the heart, and blood cells. These three things can be done bypassing the going back to an embryonic state. They can go straight from skin to this with no stops in between. And you may be saying, well, how is that a reason for me to support stem cell research? It actually is, because stem cell researchers discovered this. Okay, they also discovered cancer stem cells. These are the cells inside the tumor itself. Now, normally, this is a tumor and this is a cancer stem cell. With a normal therapy such as radiation or chemo, it's going to get rid of this, but that cell may or may not go away. They can hide and they can come back. Using a stem cell therapy, they can target just the cancer stem cells. That saves all the normal cells around it, where chemo goes in and it just wipes out everything, good, bad, otherwise. If you target just that stem cell, you're going to get rid of that stem cell. It cannot metastasize, excuse me, I can't say that word very well, which means it can't spread. And there's a very low recurrence of it coming back because it's basically gone. They just obliterate it. They go in, they found a mechanism that makes it work, that turns it on and it turns it off, and once it's off, it's gone. On CNNhealth.com, there was an article about a 16-year-old girl who suffered from spina bifida. She had bladder function problems. So using her own healthy bladder cells, they grew her a bladder in a petri dish using a 3D scaffolding shaped like a bladder. They spread her cells over it. A few weeks later, the cells produced the new bladder, and they implanted it in the patient. In a few more weeks, the bladder, after it was inside her, grew to normal size, and it began functioning. So we're talking a month. There were no issues with rejection because it was her own tissues, it was her own DNA, it was a perfect match. And now she doesn't have bladder function problems any longer. Also on CNN.com, there was an article, and I couldn't find a picture, I'm sorry. They grew a new windpipe for a 30-year-old woman who had severe tuberculosis. She had small children, and she was bedridden. She couldn't do anything anymore. They had a 7-centimeter piece of a donor trachea from someone that had passed away, and over 6 weeks they removed all the donor cells, because if there were any donor cells left on there, that poses a risk for rejection once it's implanted in the patient. After they got that off, they were left with scaffolding of the trachea, just the bare, like the cartilage of it. They covered it with her stem cells from her bone marrow, the patient, and healthy cells from her trachea. And 4 days later, after they put the stem cells on, they were able to put it in the patient, and she got to go home 10 days later. 4 days after the operation, the transplanted windpipe was indistinguishable from the patient's own bronchi. So the area they were transplanting was down in here, and all of this formed right away, and you could not distinguish it from the other side. After 1 month, all the blood vessels had grown back and began functioning, and now she can climb stairs, she can do activities with her kids, and she doesn't even get breathless anymore. Finally, let's go over some of the potential future uses of stem cells. As an article on University of Utah's website, learngenetics.utah.edu, describes, there are drugs in development right now that they're hoping they can give a patient that, like in this instance, we're looking at kidneys. Let's say your kidneys are damaged. They can give you this drug, and it will activate a certain stem cell in your body, because we all have stem cells hiding in our organs. They're just really hard to access. But it could stimulate those stem cells to go to work and repair the damaged part of the kidneys, and then you have normal functioning kidneys once again. This would eliminate the need for invasive surgeries or even surgeries to harvest the stem cells and things like that. All you have to do is take a pill. When it comes to cell-based therapy versus donated organs and tissues, the need for donated organs very much outweighs the amount available. People are on waiting lists for years sometimes. Sometimes people don't even live long enough to get their transplant. And donor organs and tissues aren't foolproof. You have to take rejection drugs, and sometimes those don't even work. So they've waited and waited and waited, and it still doesn't work. Stem cells used to generate organs and tissues are a renewable resource. We're not going to run out. Your body has them all over the place. And they can be used to treat many diseases, and they run a very low risk of rejection because it's your own tissue. Researchers are currently working on growing 20 different organs and tissues, including hearts and livers. This is actually a heart that right now is being grown in a lab from stem cells. This is a liver growing in a lab from stem cells. I mean, one day, lose your liver or lose your life could become obsolete. You could go in the hospital and you need a liver, and in a matter of days or weeks, you could have one, and it's your own. So you're not going to reject it, and you go back to life. The possibilities, progress, and potential for stem cell research is endless. Imagine being able to screen better for diseases. Being able to treat diseases with less risk to the patient. Helping people that previously had no options. It's not perfect, but nothing is. It may not work for everyone, but it has the potential to work for many people. Stem cell research gives us something that's many times lacking in the medical world: hope. It gives us hope for a cure. It gives us an option. It gives us another tool. It gives us another weapon to fight with. If you've been lucky enough so far in your life not to have been touched by a disease with no hope, either through yourself or a friend or a family member, chances are at some point in your life it's going to happen. If your loved one was in battle for their life, wouldn't you want something that would help? Wouldn't you want the doctor to have something they could try that might help, wouldn't you want an option? Wouldn't you do anything to save that person? I know I would have.